Welcome, everyone. My name is Matt Del Bono, and I'm an Extension Support Specialist with the Greenhouse Lighting and Systems Engineering Consortium. Today, you're going to be hearing a State of the CEA Industry update from our Principal Investigator, Dr. Neil Mattson, and our Executive Director, Gretchen Schimelpfenig. The first video in this three-part series will cover New York State market growth. In the second video, we'll focus on technology development. And in the third video, we will cover technology adoption and impact. Before we get started, I want to take a moment and introduce you to our organization. At GLASE, our mission is to transform greenhouse lighting and systems management to support climate-smart CEA. To do so, we research LED systems engineering, plant photobiology and physiology, and greenhouse environmental controls to commercialize emerging technology, improve business performance for growers, and reduce the carbon footprint of greenhouse operations. GLASE partners include Cornell University, Rutgers University, Rensselaer Polytechnic Institute, and our founding partner is the New York State Energy Research and Development Authority, NYSERDA. At GLASE, we accomplish our goals through research and technology transfer. We also provide a broad range of educational opportunities like our courses, webinars, and other resources in our library. And finally, we seek to help the CEA industry network, build community, and generate business at our online and in-person meetings. Please reach out to our team if you are interested in learning more about GLASE and our member benefits, and thank you for tuning in.
Welcome back. We're going to talk a little bit more about technology adoption in New York State and how GLASE anticipated things like LED horticultural lighting and LED lighting controls would be adopted and how they've been adopted in the past 5 years or so. So Neil, you thought that in 2015 or so that by now, how many greenhouses would have adopted LED lighting, and why did you think that?
Yeah, so this was a bit like looking into the crystal ball. So back in 2017, LEDs were becoming quite a bit more energy efficient than HID fixtures. However, the capital costs were still relatively high. And so there were some barriers to adoption. But looking ahead to the crystal ball, we expected that by 2024, we'd see about 60% adoption. So about 60% of lit area in New York State would be represented by LEDs.
And so when we asked our GLASE Industry Advisory Board members how that's really played out in 2024, they were a little more cautious, and they felt that around 21 to 30% of greenhouses in the country, as well as in New York State, have adopted LED. And when we talked about particularly New York State reasons why that adoptions remained lower than the 60% number, is there were a number of factors. We talked about in our previous video that we have in New York State a high proportion of floriculture growers who are less likely to adopt LED because they may not need as much light for their crops, and the payback periods may be longer. We also have a high quantity of greenhouses in general. When you're talking about the CEA industry, more indoor farms are likely to adopt LED than greenhouses. And so since we have more greenhouses than indoor farms, we're seeing a little bit slower adoption. And the upfront cost of LEDs continues to be a barrier for energy efficiency adoption nationwide, and is also affecting growers in New York State. So on the next slide, we talk about what we had said in our crystal ball. So when we were making these projections back in the day, we thought that there'd be a few different things that would happen in the past 5 years. So in 2016, we thought that integrated lighting controls for greenhouse lighting, which we call our lighting and shade system integration platform, this is not something that we thought would have to be integrated with our platform, but we hoped that by 2016, that greenhouse lighting controls with integration would be providing around 15 to 30% energy savings. And then by 2017, integrated controls with CO2 would be able to achieve 30 to 50% energy savings. And that's something that I'll talk with Neil about how we've researched ourselves with LASI. And then in our other video, we're going to talk about how we thought LED lighting systems would evolve. And so our projections were that first generation LEDs that GLASE and the industry would be able to achieve by 2018 energy efficiency performance that would give us about 35% energy savings in greenhouses. And so some of the numbers that you see on the slide here are in some units that we'll talk about, including moles per kilowatt hour, and I'll have Neil talk about that, and then also micromoles per joule. And so we thought that those numbers would get better over time. And in 2020, they would get even better. So Neil, why don't you tell us a little bit about these projections and maybe a bit about those units that are maybe new to some folks?
Yeah, thank you. So, a little bit on the units. First of all, there's two ways that we measure efficacy, which is light output per unit energy. And back when we put GLASE together in 2017, a kind of more standard unit was moles per kilowatt hour, which is total light output per kilowatt hour. And then there's a simple unit conversion to convert that to the other type of unit, which is just dividing that by 3.6. And that gives us micromoles per joule. So total light output in micromoles per joule of electricity. And the best high pressure sodium lights that were available on the market in 2017 had an efficacy of about 1.7 micromoles per joule. And so looking at industry trends, and we were able to observe even in 2016, 2017, there were fixtures on the market that approached this 2.6 micromole per joule target. They approached about 2.4, 2.5, some of the best on the market at that time. And then as we got a next generation of LED systems where the diodes are even more efficient at putting out light per unit of energy that they use, we expected that we would be able to see further energy changes. So we expected that we'd be able to see a doubling ultimately of the efficacy, which is 50% energy saving, so that we would go from 1.7 micromoles per joule from high pressure sodium lights to up to 3.4 micromoles per joule.
So let's dive into how those projections stacked out in actuality. So GLASE has been up to a lot. And so Neil, why don't you tell us a little bit about LASI and how we've been deploying some technologies for lighting controls and testing out LED lighting systems as they've evolved.
Great. So LASI stands for Light and Shade System Implementation. It was developed by a predecessor of mine at Cornell University, which is Lou Albright, and it was originally invented for using high pressure sodium lights and then making lighting decisions based on how much sunlight is available. And as opposed to traditional technologies, which are either on timers where the lights are on and off at specific hours of the day, or threshold control, where you kind of make instantaneous decisions about if the sun is dim, then you turn the lights on, and then if the sun is bright, you turn the lights off. LASI makes more strategic decisions that are integrated over the day, and it also tries to schedule more lighting to occur when electricity is cheaper during the off-peak periods of the day. And so building off of that original LASI platform, we developed and then tested, both in on-campus research and now with commercial greenhouses, several iterations of this. And one is incorporating carbon dioxide enrichment. That component was also developed by my predecessor, Lou Albright, and that takes into account the effect that if you can enrich carbon dioxide in the greenhouse environment, that photosynthesis and then crop performance is stronger. And then with some crops like floriculture crops or lettuce, instead of having additional yield, what we get is the ability to decrease the amount of supplemental light that we add. So we can achieve the same target plant growth rates or yield with adding CO2 and then having less supplemental light. So that was the CO2 LASI iterations that were tested. And then taking into account the capabilities of more advanced LEDs that are now dimmable in many cases. And in some cases, we can even dim the spectrum that they have. We developed iterations of LASI that we call real-time LASI, where we complement the sun. So we also run this logic in the background. Do we need to add supplemental light? Can we wait till later in the day when electricity is cheaper to add supplemental light? But if we do need it, our LED fixtures don't have to be all on or all off. We can complement sunlight to achieve an instantaneous lighting target. And what our own research has found is that is more efficient for the crop. We don't overload them with light or stress them out. So we can deliver that same daily light integral and spread it over more hours of the day and get more effective crop growth. And then some final iterations on LASI which we've tested in a virtual environment, are what we call the day-ahead market price LASI, or DAM LASI, where we look at the electrical rate structure in 15-minute increments for the next day. So times of the day that would have peak electrical demand when electricity is very expensive, we would not want to add light during that time, and we would wait till times of the day, if possible, when electricity is cheaper, and still hit our daily light integral targets.
So there's a lot of ways to save energy with greenhouse lighting controls, as well as save money by choosing when to use supplemental lighting. And so to reiterate, we thought that when looking back, we thought that in 2016, lighting controls integrated like LASI would be able to achieve 15 to 30% energy savings. And then later with the CO2 controls integrated along with the supplemental lighting controls, 30 to 50% energy savings. So what's been happening in the industry? There's a couple things happening, including with the Design Lights Consortium. So the Design Lights Consortium created a networked horticultural lighting controls working group. And that's been convened for probably a year now. And GLASE has been involved, and there's going to be some exciting, hopefully technical requirements that will come out of that. The horticultural technical requirements for light fixtures version 3.0 already requires fixtures to be able to be dimmed, which is great. But now there's also hopefully going to be technical requirements that will come out for horticultural lighting controls products themselves. So things like energy monitoring might be a requirement so that standardized energy reports could come out of lighting control systems, and we'd be able to understand how much energy is saved by things like DLI controls or other sorts of versions of LASI. And so if we go to what the GLASE Industry Advisory Board members have said, when we asked them this year how much you think advanced greenhouse lighting controls have been adopted and how much energy they're saving, they feel like it's on par with what we projected for LASI of 15 to 30% energy savings. The CO2 projected energy benefits are something that we have a little bit more to say on. Neil, would you like to chime in about that in terms of what Cornell has found in our experiments?
Yeah, so in our own experiments, which have been with lettuce, strawberries, tomatoes, and hemp with CO2 enrichment and then using CO2 LASI, we found savings averaging about 41% versus status quo lighting control. And we have been able to implement this at one commercial facility in New York State, which is Wheatfield Gardens. However, I would say I'm not surprised that GLASE members are not reporting out more substantial CO2 supplementation benefits. And I think this is for a couple reasons. CO2 has gotten more expensive in the last few years. If you have an on-site source of CO2, which is the exhaust from your boiler systems, that's still a very viable, very cheap form of CO2, as long as it's cleaned and doesn't have off gases that can hurt plants. And then, as Gretchen was mentioning earlier, we have a disproportionately large number of floriculture greenhouses in New York State versus vegetable greenhouses. So they typically don't use carbon dioxide or get to take advantage of that for their crops. And then tomato producers are our largest vegetable segment. And tomato producers, instead of using CO2 to have lower supplemental light settings, what they are probably doing is using CO2 supplementation to get higher yield in conjunction with their existing supplemental light targets.
Yeah, so maybe not changing as much, just wanting to get higher yields. So
Mhm.
not saving energy, but getting those higher yields. So let's show a bit about how we've deployed some of these systems in New York State. Any thoughts on how LASI's been deployed in New York State and maybe some things that are in progress in 2024, Neil?
Yeah, so at this point, we've deployed LASI at 6 and actually more than 6 operations, and deploying it in various iterations. So the traditional LASI on off can work even with facilities that have high pressure sodium lights, for example. And then facilities would need to have carbon dioxide enrichment or dimmable LEDs to take advantage of the newer versions that we've developed for LASI. One of the things that we found in implementation is our industry is very diverse. The greenhouse industry is very diverse. So everybody has different crops that they're growing, from floriculture crops in the propagation stage is where they're often adding supplemental light, to herbs, to leafy greens, to hemp, and so on. And so everyone has different lighting targets. And to some degree, they also have different objectives with their lighting control. Sometimes their objective is just to get greater uh, quality assurance, or like standardization of their crop cycle. So if I'm propagating floriculture crops, it may not necessarily be the quickest growth, but I want to have, say, 4-week production cycles for each crop and be able to execute that consistently. So for those types of growers, the benefit of Lassie might be just better control of DLI in general. And then for other growers that are selling crops based on yield, like leafy greens or basil, then actually having that higher yield output with reduced supplemental lighting costs is the benefit of Lassie.
Great. So that's our talk on lighting controls and how it's been adopted in New York State for greenhouses. And our last video will be about how New York State has adopted LED horticultural lighting in greenhouses.